If you're working on transmitters with analog modulation, such as narrowband FM for land mobile radio, wideband FM for the broadcast FM band, or the broadcast AM band with wideband AM modulation, or even narrowband AM for the airband, then you'll definitely appreciate the benefits of option AFM on the Agilent handheld spectrum analyzers. Without option AFM, we can of course tune into a signal. I've got here a 450 megahertz carrier, narrowband FM modulated, so I can type a center frequency of 450 megahertz and enter a span of, say, 50 kilohertz. And you'll see the typical FM modulation pattern you'd expect to see. But it's very difficult making accurate measurements of this, such as the deviation values or actual center frequency. So that's where option AFM comes into its own. If I press the mode button and press modulation analysis and select FM, we can now enter a carrier frequency of 450 megahertz. And I need to tell it what IF bandwidth we're using, but in fact, if you don't know, just press it onto Auto, and the Auto IF bandwidth feature on the analyzer will automatically work out the optimum IF bandwidth for the measurement. And here you can see the 1 kilohertz tone that I'm modulating on this FM carrier from the signal generator. And we have an oscilloscope display on the top of the screen. You can see here on the x-axis we have time in milliseconds, going from 0 to 10 milliseconds, and on the y-axis we're measuring FM deviation in kilohertz. And best of all, in the table at the bottom of the screen, you can see it's telling us the carrier power, the current value in dBm, the modulation rate, 1.00 kilohertz, that's the frequency of our test tone, and you can see the FM deviation, 3.01 kilohertz. It even measures the synad of the signal, currently 53 dB because we've got a nice strong carrier, and it even tells us the carrier frequency offset. That's the error from the nominal carrier frequency of 450 megahertz that the analyzer is measuring. So you can see the carrier frequency of this transmitter is about 120 hertz high. If we were measuring a 25 watt mobile radio transmitter, we'd obviously need an attenuator. These analyzers can handle a maximum continuous input power of plus 30 dBm, but for a 25 watt transmitter, you'd need an attenuator such as this. We simply insert this between the transmitter and the RF input on the analyzer. If I press the More button, you can see that we can enter a value for the external gain, or in this case attenuation of the attenuator, and still therefore obtain calibrated readings on the display of true RF power. And we can do exactly the same with an amplitude modulated transmission as well. If I change the modulation on the signal generator to AM, we simply press Measure, select AM, and you'll see that the automatic IF bandwidth function has automatically worked out what IF bandwidth the analyzer needs to measure this modulation rate. The x-axis of the oscilloscope display still shows us the time in milliseconds, but on the y-axis it's now measuring AM depth in percentage. So if we look at the table, you can see the current and max and min values of carrier power, modulation rate, still 1 kilohertz, the AM depth, approximately 50%, the synad, and again the carrier offset. That's the error in carrier frequency from what we've set, 450 megahertz, to what the transmitter is actually generating.